Hi everyone, I hope you are well and safe and preparing well for your upcoming NEET and JEE exam the same time. Here we have come up with a crash course to help you in this and I'll be teaching you physics. So आज आपके 11th क्लास की फिजिक्स का शुभारंभ होने जा रहा है with the very first chapter unit dimension and measurement. Though in sequence this chapter comes as second chapter in your NCERT book, but from physical world questions do not come in competitive exams, so we are starting with the second one. So please be attentive and let's get started. I hope you will enjoy the chapter. So it's unit, dimension and measurement. The first thing is what is unit. As you can see, a basic reference used to measure a physical quantity both quantitatively and qualitatively is unit. Right? So what is unit? Unit is a reference. You can say if a given object is having length 5 meter, what does it mean? Its length is 5 times the reference length, that is 1 meter. Right? So for this measurement, reference has to be used. That reference is called unit. Another thing is there, quantitatively and qualitatively. So quantitatively means that if you are writing 5 meter, so that 5 represents the quantity. It does show that it is 5 times the reference value, and qualitatively when we are saying meter, it does show that it has to be a length. The physical quantity that is to be measured is a length. So unit is a reference used to measure a physical quantity both quantitatively and qualitatively. Now we can categorize unit in two parts. First is fundamental unit and other is derived unit. What is fundamental unit? Fundamental unit is which cannot be expressed in terms of other fundamental units. Like we cannot express mass in terms of length. Can we? No. Or can we express time in terms of distance? No. This also is not possible because these are all fundamental units. Here is the given example for all 7 fundamental units. So there are only 7 fundamental units. Other than these 7 units, all the units in universe are derived units. So derived unit is which can be expressed in terms of fundamental units. Now for length, it is meter. For mass, this is kilogram. For time, it is second. For electric current, ampere. For temperature, Kelvin. Amount of substance, mole. And luminous intensity, candela. These are the 7 fundamental units. Now we can see that length, mass, time, amount of substance, temperature. These are actual 5 fundamental units because other than these 5, one is electric current and one more is luminous intensity. As of now, we know that electric current is not fundamental. It can be defined as rate of flow of charge. The same is with intensity. Now we know that intensity is energy per unit time per unit area. So these two are actually not fundamental units, but conventionally, since when these were defined, from that time it is taken conventionally as fundamental units. Now other than these 7 fundamental units, 2 supplementary units are there. One is plane angle, other is solid angle. Now what is plane angle? Plane angle is angle made by a line element. Angle made by a line element at a point. Diagrammatically, we can show plane angle as if this is the line element and it is making an angle here. So the angle will be plane angle, delta theta. How this can be measured? Delta theta can be measured as length of this line element upon perpendicular distance from the point. So delta theta can be written as L upon R perpendicular. Now unit of plane angle is radian. It is the SI unit. All the units that we are taking are SI units. Now comes solid angle. Now how this is defined? Solid angle? Angle made by an area at a point. Instead of line element, now it is area that is subtending the angle at a point. Diagrammatically it can be represented F. It is the point. So just join periphery of the area element to that point, and this three-dimensional kind of angle, generally it is denoted by delta omega. This is called solid angle. It is measured as area upon square of perpendicular distance. SI unit of solid angle is steradian. After knowing unit and how can we calculate it? See, if we know the physical quantities that are involved to express a given physical quantity, of course we can express its unit. If we know a given physical quantity depends on how many basic physical quantities, we can write its unit as well. We will see this later into example. Now come to parallax. Parallax is something very interesting thing, so please do listen. First make a mark at your notebook. Right? Now close your left eye and look at the mark from your right eye. Right? Now do this with left eye. Can you see its dislocation? Of course the mark is at the same point, but still it seems dislocated. So this virtual dislocation, because the mark is at the same point, so we can say the dislocation is virtual. Virtual dislocation of an object when it is viewed from two different locations is called parallax. So if it is the object and it is viewed from, let this one be the two places from where it is viewed. This is line of vision from S1, another line of vision from S2. The angle is called parallax angle. This parallax angle is responsible for its virtual dislocation. If we look at an object which is at infinity, these two lines will be almost parallel. Delta theta will be 0. So if we are looking at an object which is at infinity, we cannot experience this parallax. It is only for the object which is at some definite distance. And how can this be measured? Delta theta can be written as, if basis is defined by L and location of O from S1 or from S2 is R, of course delta theta can be written as L upon R. But this will be valid only if delta theta is small. So it is the condition, if delta theta is small, we can write delta theta to be equal to L by R. Now we will see why parallax is needed, why we are studying this parallax. It is a very useful concept which can be used to measure very long distances indirectly. So let us come to that explanation. Application of parallax. It is used to measure long distances indirectly. Here we can take example of distance of sun from earth. So let this be the sun and these are two locations. Let us consider one location is Jaipur, another is Delhi. So from Jaipur, first you are viewing the sun, and again from Delhi. So these two will be line of vision and theta is angle of parallax. Now since these two locations are on earth, so we can write distance between Jaipur and Delhi, always we know the distance. So this D is known thing, and we have to calculate distance of sun from the earth. Now you can see it is immaterial whether we are measuring distance of sun from Jaipur or distance of sun from Delhi. So since theta will be very small, for astronomical objects if we view it from earth, the theta parallax angle is of the order of 1 degree or even less. So angle of parallax formula is applicable here. Now we can write theta is equal to D upon R. Of course this R will be an approximate distance, but this is quite reasonable, or R can be written as d upon theta. It is very useful formula to calculate very long distances indirectly. It is not possible to measure this long distance from any kind of measuring tape. So indirectly we have to measure the distance, and it can be done with the help of method parallax. Here you can see this r is calculated. Always do remember, while using the formula, theta has to be in radian. Never write the value in degree, right? Let us consider one example. We can solve an example based on this parallax. The question says the sun's angular diameter is measured to be 1920 second. Now what is angular diameter? Angular diameter is the angle that diameter of sun is subtending at any point on earth. Here you can see this angle theta is angular diameter, and this is diameter of sun. Let that be represented by L. Distance of sun from earth is given, which is represented here by d. We can apply the formula delta theta is equal to L upon d, and since we are interested in calculating L, so L will be equal to d delta theta. Now you can substitute the values. D is 1.496 into 10 to the power 11. Always remember delta theta we have to write in radian into 1920. Now this is in seconds, so first convert it to degree. 3600 seconds is 1 degree, and then convert it to radian. Conversion is multiply this by pi upon 180. After calculation we will get the value approximately 1.39 into 10 to the power 9 meter. So this is how parallax is used to measure long distances indirectly. Another method is there which is called volumetric method. Volumetric method is used to measure very small distances indirectly. First we learn to measure long distances indirectly, and now it comes small distances. This is done by volumetric. The method that is used in laboratory is, it is used generally to measure molecular diameter of oleic acid. So how is it done? 1 ml of oleic acid is taken. Oleic acid has an property such that it spreads as a single molecular layer if spread on a water surface, and with this 19 ml of alcohol is mixed. This is soluble in alcohol. It is not soluble in water. When poured on water surface, it makes a circular patch. So 1 ml of oleic acid is taken, and in this 19 ml of alcohol is mixed. What we would get? This is 20 ml of solution. Now as we can see, strength of this solution will be, strength is its concentration, that will be equal to 1 upon 20. Again from this solution 1 ml is taken. So 1 ml of solution again is mixed with 19 ml of alcohol. So again it is being diluted. We got 20 ml of solution. Now strength of this solution, it has become 1 by 400. If we take V ml of this solution, what will be the amount of oleic acid in this? V into 1 by 400, because its concentration has become 1 by 400. So this is the volume of oleic acid in the solution. Now what we do? We pour this solution, V ml of solution, on a water surface. First lycopodium powder is spread on the surface. Lycopodium powder is the same powder we use for carom board. You must be familiar with this. And after pouring the solution on water surface, it is left for some time. So after leaving for some time, alcohol is evaporated and only oleic acid remains, and we can see a circular patch is formed. So with the help of vernier caliper, diameter of that circular patch is measured, and we can write, after measuring diameter of circular patch, if d is the diameter, pi d square by 4 will be area of that circular patch, and if it has thickness t, then this must be equal to volume of oleic acid, because now after evaporation of alcohol only oleic acid is remaining. So volume of oleic acid has to be equal to volume of circular patch, that is equal to area of cross section into thickness of patch, and it can be equated with the volume of oleic acid in the solution. On solving, we can write thickness of circular patch has to be equal to 4V upon 400 pi d square. Now what is thickness of this circular patch? Oleic acid has a tendency to make a monomolecular layer. When spread on water surface, it makes a monomolecular layer. So when we are measuring its thickness, actually this is diameter of the molecule. In this way we can measure diameter of a molecule, which cannot be done directly. Now again let us see an example based on this method. A drop of olive oil of radius 0.25 mm spreads into a circular film of radius 5 cm on the water surface. Estimate the molecular size of the olive oil. Now when it spreads as a circular patch, that will be equal to pi r square, which is area of circular patch, multiplied with thickness of patch. This is equal to volume of olive oil. Now what is volume of olive oil? Since it is a single drop, so that has to be equal to 4 by 3 pi r cube. Now see, this capital R I have written, this R is radius of drop, which is equal to 0.25 mm, and another this small r is there, this is for radius of circular film. So from here we can calculate T, that will be equal to pi gets cancelled, 4 by 3 r cube upon r square. On substituting the values, this one is 0.25 mm, 10 to the power minus 3, and then cube of this upon 5 centimeter, 5 into 10 to the power minus 2, and square of this. On solving, the answer will come out as 8.3 into 10 to the power minus 9 meter. I hope you got all the concepts clearly. Now let us practice some questions. Question number 1 is Newton second is the unit of. Now we all know Newton is unit of force multiplied with second. So force into time. What is force into time? That is change in momentum, delta P. So third option will be correct. Next question is, which of the following is not represented in correct unit? The first option, stress upon strain, Newton per meter square. As we know, strain is unitless, it is length upon length term. So stress has unit, force per unit area, that is equal to Newton per meter square. So this one is correct. Now come to second option, surface tension. Surface tension we define as force upon length. So this is also correct, Newton per meter. Third option is energy, kg meter per second. So kg is for mass and meter per second is velocity. Mass into velocity, that will be momentum. Third one is not correct. Next is fourth, pressure. Pressure is equal to Newton per meter square. This is also correct. So third option, which is not correct unit wise, is the correct option. Now come to the third question. A suitable unit for gravitational constant is. For this, let us write the formula for gravitational constant. This is gravitational force, F is equal to G m1 m2 upon r square. You all must be familiar with this formula, or G can be written as F r square upon m1 m2. If you check by writing unit of all the physical quantities, we will get that correct option is, because it will be Newton meter square upon per kg square. Which option is this? The third option. After this, let us come to question number 4. SI unit of pressure is, first option is Pascal, then dynes per centimeter square, third is centimeter of mercury, and fourth is atmosphere. We all are familiar of this unit of pressure, which is Pascal. It is a very popular unit. Now come to question number 5. The unit of angular acceleration in the SI system is. It is asking for angular acceleration. Let us write the formula. We denote angular acceleration by alpha, which is written as d2 theta upon dt square. Here theta is angle, that has to be written in radian upon square of time. So it has to be radian per second square. Third option is correct. Now the last question. The unit of coefficient of viscosity in SI system is. The given units are here. Let us see what is the formula for coefficient of viscosity. Eta is equal to, coefficient of viscosity is defined as stress upon strain rate. Now stress can be written as force upon area, this whole divided by strain rate. As we know, strain is unitless, so it has to be only time inverse because this is rate of strain. If we put the units, that will be, for force we can write mass into acceleration, so it is kg meter per second square upon area, which is meter square, and then time inverse, again this is s minus 1. Collectively it can be written as kg per meter per second. So fourth option is correct. Let's proceed further to question number 7. This question says the equation of a stationary wave is y is equal to 2a sine 2 pi ct upon lambda cos 2 pi x upon lambda. And it is asking which of the following is correct. Different options are given here. Now we have to check unit of ct lambda x 2 pi c by lambda 2 pi x upon lambda t c by lambda and x by lambda, right? So let us start with option number 1. Now from the question we can say that this function 2 pi ct by lambda must be unitless. What does it mean? 2 pi is already a numeric constant, so ct must be having the same unit as lambda, or we can say it's a distance term. Similarly, from the second term cos 2 pi x by lambda, it can be said that 2 pi is a numeric constant, so x must be having the same unit as lambda. With the help of these two expressions, now we can check each one of the option. Option number 1, ct is same as that of lambda. Yes, from first expression itself this is correct, so option 1 is correct. Second is x is same as that of lambda. This is from equation number 2. Second option is also correct. Now come to third, 2 pi c by lambda. Here we know that unit of ct is equal to lambda. So unit of c will be lambda upon t. The term 2 pi c by lambda is appearing in third option. If we write c also as lambda by t, then it will be, unit of this will be equal to lambda by t into lambda. Lambda got cancelled, so it is t inverse. Check the second term, 2 pi x upon lambda t. 2 pi is again a numeric constant. X is equal to that of lambda upon lambda is x, so this also is x t. This also comes as t inverse. So third option is also correct. The fourth one is unit of c by lambda is same as that of x by lambda. Now see, the term x by lambda both is having the same unit. X and lambda both are having the same unit. So this term x by lambda has to be unitless. This is unitless, but come to c by lambda. Just now we had derived what is c. C is equal to t inverse. It is lambda by t. Now come to the term c by lambda. C by lambda we can check from here. C already we had derived. It is lambda upon t. So this will be equal to lambda upon t and then lambda in denominator. This will give t inverse. Now 1 is unitless and this is having unit of t inverse, that is second inverse. So this one is not correct. 1, 2 and 3, these 3 options are correct. I hope you thoroughly enjoyed the session and now you can solve questions based on unit if it comes in your exam. Good luck. Bye.